There you go.
Recording. So, good morning, everyone. I'm Georg and this is Max, and we're presenting the web development basics. We're from Project F, and we're responsible for delivering a nice website with all information bundled together. So, what is exactly web development basic? We need to know about document object model. This is DOM. We're talking about the whole seminar. This is actually an API which gives us an opportunity to create nice looking HTML files and well-structured XMLs. We're often using XML files for representing data, and it works for almost every kind of system. But we are concentrating us right now on HTML, and this is we can traverse trees, we can create new objects, and we can delete, we can find, we can change. You'll see it in a few examples here. The whole thing is made with JavaScript, and it's a bit tough to make it really all the time. So we're using jQuery and Mootools and other things to make it a lot easier and concentrate on our code and not on the DOM objects by themselves. So how does it look actually? It's a tree. It's not your code, it's not your source code. I mean, it's not the HTML you write. It's neither the view source of the web page you see. It's actually this view of your browser. When you click on F12 or something like that, it's the DevTools. There is a nice representation of the tree. It's an HTML head. You have head, and then you have body with the elements in itself. So this is a very simple web page right now. It's saying hello JS Seminar. Yeah, as I said, it's well structured in a DOM tree, and we can address every element in the website. So if we split it up, it looks like this. We start in document, and this is the doc type. No, I mean, yeah, it's a whole file, and it's split up in doc style and doc type and HTML, and then you can traverse and go to the bottom. For example, go here, hello JS Seminar. It's also an element. Everything you see here is an element. Even the white space between head and title is a white space. It's an element of the DOM, and it is represented by empty space, a new line. So if we want to traverse the tree, we can simply write it in the console, document child nodes, and this would give us the information about children of the node. It's the root. So mainly every single node of the tree has a parent, and only one parent, except for the root, which has no parents. Here, this is the root we're seeing right now. It's doc type and HTML. If we look further, we'll see that it's an array, and I prefer to choose HTML. This is the second element. It's number 1 in the array. And then we see also the child nodes of this array. This is exactly this white space, I mean text. This is the white space between head and body. So if we go further to the bottom of the tree, we'll be using also these child nodes, and child nodes. We can make it recursively, but it's it's not a big thing. How does the white space look like? It's a simple field, which is a new line. So yeah, we go to the bottom of this hello JS Seminar, and this is the content of this block of H1. This is the title. So if we want to go up the tree, and we're using this parent node. So if if we're here by Hello.js Seminar, we simply say that h1 is this node, and we go further up from h1 to parent node, and then parent node, parent node, parent node, till we get to the top. It's document actually. So we can add some nice styles, make some cool effects with JavaScript, CSS. I'll tell some nice stories about JavaScript, how we'll make ourselves useful about this. Here we can find elements inside of the tree by simply searching for it with JavaScript. The top line is JavaScript get the elements by ID, and it's simply an identifier inside of the HTML tag. Here, and with a $sign, we see jQuery, and we have made this so to make a difference between them. I simply prefer jQuery because it looks nicer and easier to write, and faster to write in code, not efficient. So this gives this returns an object, and this returns an array of objects. So it's nothing so special. We are selecting some elements by name. They're all tags, and we are using this name inside. For example, name is equal to, for example, example. We can also create elements using JavaScript and jQuery. It's again really short in jQuery. So we are creating a button here right now. And when we create an object, we most probably use this to append it to the element. So it's a nice example here right now. We can create new objects by clicking it. We can make it how much we want. So when we imagine that we have this document right now here, these are three divs in the HTML files, and we want to add some elements before the first ID. Let's say it's 0.9, and it's kind of long and ugly with JavaScript to write it and define it inside the tree. It's before begin, and the function is insert adjacent HTML. So as you can see, JavaScript gives us indeed the possibility to write it in a pretty cool way. And this is the result. We have this here at the beginning. So we have other possibilities. For example, we can add an element after, inside, or before the element. When we use after begin, we attach this new element, write it after the beginning from the div, and when we use before end, then we add this right at the end of the element. After end is self-explaining. So we want to add childs to a node. For example, we begin with parent and out child, and this is the JavaScript code. We find the parent with get element by ID and insert adjacent HTML after begin. So it's equal to prepend in jQuery, and this is kind of the difference between these adjacent thing to add these nodes, and jQuery is making this the same way with prepend and append. So this is the new child we're creating. We can move, we can delete. So how we move the elements, we have an orphan, we have a parent, and the orphan is outside of the parent. So to move it to the parent, inside of the parent, we are simply deleting it from this current place and then add it to wanted. So it most probably come before the end because we're using append child, and that means it comes right to the end. So how are we doing it the other way? We can insert them at the beginning. How are we removing elements? So it's pretty ugly in JavaScript right now. Do you have some suggestion how it would look like in jQuery? Yeah, it's one word, it's remove. So we can also remove, attach, change attributes like if we imagine that this div is working as a button, yeah, it's kind of deprecated. But if we want to make it interactable and add some events to it, then we can change attributes, set attribute or remove attribute, and this is actually this row. jQuery is easier and really convenient to see and read the code. So this is our result. The row of the button is here, and this is it's added right inline. How are we changing context, text content? There are 3 ways to add this. So we have at the beginning this div, it's hi there, and this is our content. If we want to change this content to goodbye, we can use all of these 3 functions.
What would be the difference between them?
You mean this question? What is the difference? Yeah, the first inner HTML shows us that we can extract every tag in the content. For example, this is something new. We are taking everything with the HTML tags. I mean, it's not escaping. Yeah, the difference between adding and taking some content is here, because when we want to add some content, we don't see any difference. They work the same. But when we want to take the content of the div, then there are some ways. This is the Microsoft way. They kind of like creating new names for everything, and this is the DOM way to text content.
What is the Microsoft way?
Inner text, they have created it, as far as I know.
Microsoft being what?
They like being creative and things like creating new names for some kind of things. They already exist. Yeah.
So is this? Wait. So you're saying this is how it's implemented in Internet Explorer, or this is what does it mean? The Microsoft way?
Yeah, I think so. That it's implemented in Microsoft Internet Explorer because at the beginning JavaScript was so uneasy to use, and it was so strange. Every browser had these different requirements.
Wasn't there just 2 browsers in the beginning, Netscape and Internet Explorer?
Yeah, right at the beginning, yeah.
So saying like every browser out of these 2, you know, it sounds just funny.
Yeah, you're right. So this is it, how we basically add and remove and change content of the divs. Max will show us how we can make it more beautiful with styles, and yeah.
Okay, so before you do this up, what I've seen up until now is essentially a nicer syntax that jQuery introduced over native JavaScript. Is that the difference? Is that really the difference between what jQuery is giving us versus native?
No, it's not really only beautiful syntax. It's also added a lot more functionality. so we can concentrate on our code. For example, there are some animations that take a lot more code in JavaScript. Is this what you mean? By your question?
I think the question is pretty simple. Is the difference between jQuery just giving us a nicer syntax, a cleaner syntax than what the native JavaScript gives us? So the JavaScript syntax gives us the document access, whatever, modifier.
Nowadays, every browser has some requirements. It's different to display the DOM, and jQuery kind of unifies these styles and ways to show the content.
To extend this, actually, if you select an element by jQuery, you don't get a plain DOM element back, but you get a jQuery object back.
Right.
And as part of those jQuery objects, jQuery is adding a lot of functionality, like making stuff easier. You can use the jQuery object and make stuff which isn't possible with DOM elements.
All right, are we going to get the under the hood jQuery coming in the next slides, or this is going to be what jQuery provides? Because what I really would like to know is how does jQuery works under the hood? Like there's what objects are we getting, what kind of functionalities?
At the first we were just focusing on plain JavaScript, and after Dimitri sent us feedback we should add jQuery. We just added jQuery as a comparison to plain JavaScript. So we didn't dive deeply, or we do not dive deeply in how jQuery works under the hood.
Okay. All right.
So now we have our DOM, but I think we all want to make it look prettier, just because just having a DOM is not what we like in web development. And this is where CSS comes in. Basically, you can, I will explain you the syntax of CSS first. You have a selector, and a CSS selector selects an element in the DOM tree. And in the curly braces, you are able to define properties of this DOM element. For example, you can define a color property and assign it a value. Or you can declare a font size value. So I will show you some pretty basic selectors. For example, this paragraph selector. You can select every DOM element by writing the name in CSS. You can select DOM elements by using its ID. This is a kind of shortcut in CSS that you can write hash and the ID. At this example, we see we are overriding existing styles. So the first CSS rule we have is select all H1 and H2 elements and assign them the font color white. And at the next line, we are doing select every H1 element with the ID slogan and assign the font color 101010.
How many elements can we have with ID slogan?
The idea, that's a good question. The idea with IDs is that they should be unique in the current, let's say, context of the page, so that when you select something by ID, that it should only return one element that you're styling. The other concept is that you have classes, and classes are, well, classes or bundles of similar objects, and you can assign styles to all of those objects. It's just more or less a syntactic idea how to structure your CSS code better. Here we get some classes. We have an input DOM element, and the class is button and button primary. So this element has two classes assigned. And on the right you see we are defining for all button elements a padding of 15 pixel. And the primary button has furthermore some elements like a green background and a white color. This way it's pretty easy to define, let's say, all basic buttons. They should have a padding, and then you have a primary and a secondary button, and they might differ, but both of them have a padding. And you can do CSS inline. If you write your CSS directly to the DOM or the HTML element, you can do it with style equals. Exactly. Do we have any questions to those basic selectors? Then let's move on to some more advanced ones. At the first example, we are selecting a paragraph, which is a child of a div with the class name column. If you think about the examples before, we have a div container with class column, and inside we have more or one paragraph elements. At the second example, you see we can select kind of attributes. If we say we want to select from one div, if you take the first example, div.column, first child, we get the first child of this div container. You can also do this with every child if you know which position it is. However, this is kind of difficult or might give you problems in the future because it's pretty hard coded actually. If you have something like select the fifth child of 10 childs, you might think about adding IDs or classes. And the last child is pretty convenient as well. So furthermore, we can say something like, okay, let's go to the div column and select the nth of the type paragraph. Like in the third example, we can say we want the second paragraph in this whole div container. So if you have kind of headings and paragraphs inside of a div container, first child or nth child wouldn't give you this result. You can say I want the second paragraph inside. You can, in CSS3, you can react to events. Those are some simple events. Hover, active, focus, check, disabled. Hover is when you mouse over an element, then you can, that's how you select this event, and you can change the styles according to it. Same with something like checked. If you have a radio button or a checkbox, you can select checked checkboxes to have a green check mark or something like that. Furthermore, you can select before and after an element. So if you go to paragraph before, you can add content to the DOM element before and after. So you can go and say every link, every HTML target should have a little arrow before. We can also select elements by their properties. So we can go and say we want to have we want to select every HTML tag which targets to a PDF document. So you can make kind of regex syntax here. You say the href attribute has to end with .pdf. The same works with, for example, the type. You can select every input field with the type radio. Do you have questions to the advanced selectors? Okay. So we didn't talk about what is the cascading part in cascading style sheets. Basically, the idea is you have different layers of styles. So for example, your web browser has some default styles for example, mouse overs for links or something like that. And you can override those browser defaults by adding your own styles. The way how overwriting works is the browser defaults are always the lowest ones. Then you can load external style sheets from Bootstrap or something like that. Then you have internal style sheets where you reference your own style sheets. And the last one is the inline element style, which I showed you earlier. You have the style directly inside of the HTML tag. And you can override all of those four by adding the important expression to your declaration. I see a question?
No.
Okay. So keep in mind, important is pretty powerful because you can override stuff. However, you need to know where to assign the important to, because sometimes it overrides too much.
So overriding, important just give a certain preference, essentially? That's what the important do it again?
If you think about, you have a lot of libraries added to your website, and some of them might have bad selectors. For example, they say .container, and the library is selecting all classes with the container, all elements with the container class, which is probably a bad idea. But however, if that happens, you have the possibility to override it inside of your styles.
Okay. This is in CSS, which version?
I don't know whether it was already there in CSS2. Maybe some of you guys know it was in CSS2. Okay.
Right. So it's widespread. It's essentially.
Yeah, absolutely. It's widespread. But in your daily developing, you should try to avoid it, because it just, at some point you don't know why CSS styles are behaving differently or strangely. Sorry?
You can simply say this by saying it violates the purpose.
Of the important rule?
Of the
cascading, yeah, that's true. It's, as I said, it rules them all. It's a very powerful tool, but you should be cautious. Okay, let's move on. It's not.
There's something which I'm missing, which comes with CSS version 3. Yes, you can implement animations, and it has been done very often with JavaScript in the past. But CSS3 introduces some things that you can do animations with, right?
Yeah, we have a little example of it later on. However, we are not diving into deep of keyframe animations. But if you speak to it now, until CSS3, most people did their animation stuff with JavaScript. Moreover, with extra libraries like jQuery or even more bloated ones. And now CSS gives a nice way to animate basic stuff and even not so basic stuff, as you will see later. So it's a good alternative to heavyweight JavaScript animations. Is this enough for your question, or okay? We will see a nice example later on. It's not just about styling simple elements, it's also about styling, not styling, but layout the whole page. And this is where some frameworks like Bootstrap or Foundation came in. They bundle a couple of things. For example, they bundle certain CSS rules you need in your, or want to have in your every project. They bundle some JS extensions and, for example, icon fonts or normal fonts. Furthermore, when you do some web projects, you're mostly using buttons or a navigation bar, and most of those frameworks are providing you those. And one of the most important parts is that you have a kind of grid system in case of Bootstrap 3. And I will dive into this. So you have the problem when you just take the DOM and write it below each other, you would need to use CSS to, for example, float something to the right or float something to the left.
Why not just use a table?
This is actually a pretty good question. Tables have worked a pretty long time, and everyone used tables in the past. But one of the big problems that tables have, that such a grid system is solving, is that this grid system can change dynamically depending on the screen size. This is something that tables are not able to do nicely. For example, if you take this grid and you show it on a desktop machine like this one, you will present it, all the columns. The column, MD8, and forever are those div elements you see below there, so you can add content to the column items. And if you take a look at this grid on a smartphone or tablet device, the grid is going to change. So it's adapting, the content is adapting the screen size. The term for this is actually responsive design. And that's mainly the reason why tables are not suited for today's design or layouting.
Well,
do you agree?
They started being phased out even before mobile devices became the most dominant.
That is just because you can build all those table styles or layouts with normal div containers. And you had a couple of advantages by using div containers and make them behave like normal tables. Yeah, I think that might be one of the main reasons that tables started to fade out.
Well, as far as I know, it was basically two reasons. First, the idea of semantic web was very huge at the time of phasing out tables. Because you know, a table is something that's supposed to hold just table of data. And if you have simply lots of information, you really would need to put it into div if you care about semantic web. And that idea, like I said, was very big at the moment. And second, tables are not maintainable at all. If you create any complex enough layout with a table and then suddenly you realize you have to move around elements a bit, you will have to just draw it again, try to redraw the grid, and then go through all of the text and change the whole structure.
Yeah, they are not that flexible, that's true.
You don't need to change the structure, you simply need to change its representation, the way it looks.
That's a pretty good point, yeah.
And then mobile devices came, took the net by storm, and now we have responsive layouts as well, which would be impossible to do with tables.
Yeah, you got a pretty good point that tables are not that flexible like making div containers or grid systems. So this way you can define, you have a row, in this example 4 rows, and you have a maximal column size of 12 in the case of Bootstrap. And now you can define column width, for example, a column of the size 8 columns, and to the right of this there is space for other columns. And then you can nicely partiate your layouts or rows. As I said, or as it's pointed out at the slides, there are different classes provided by Bootstrap. For example, there's column XS or column LG for large, which target specific device sizes.
Can I apply both MD and LG classes to the same node?
Of course. Then if you do it this way, you want to behave it differently. So if you have a grid, it breaks at some point, because if you shrink it down to the tablet size, it breaks at the point you specify. If you specify it with the MD8, it's going to break at the end of those MD8 columns. And if you add a large or XS class to it, it's going to break differently on the corresponding devices. Yeah, let's talk about some other stuff, because CSS files can be pretty hard and pretty large, and there are ways to make it easier to program your CSS styles. This is where CSS preprocessors come in. The most important ones are less, sus, and SCSS. What are they for? They extend the features of CSS. For example, they introduce variables. So we can define a variable and use it at different points on your styles. This is pretty awesome if you are using colors, so you can define a brand color and use it at different points. Furthermore, you have, for example, nesting. You can say, if I want to select multiple classes in sites, or you have a nested selector, you don't need to write the nested selectors, but you can nest the declaration itself. And mixins are a pretty cool advantage as well. Less actually works in most modern browsers. However, it makes sense to pre-process the less files in CSS files manually before you deploy it on your web application. This is done primarily by Node or some other preprocessors. Let's have an example of less. As I said, you can define variables. You do this by using this @ sign. And below here, we're using this variable and saturate the color, the base color by 5% and assign this color to this box. Yeah, exactly. And this is pretty cool because when you now want to change your base color, you can do it at one place and it will affect the whole website. If you compile this less file, it becomes like this. The saturate is applied, the lighten is applied, and the box shadow gets the base color. Now let's take a look at mixins. At some point you want to reuse certain sets of style declarations, and therefore you can write mixins. As you see here, we define for the class A and the ID B a color red, and now we have a mixin class, and we might have a different div container which should have the same attributes or styles like the class A. Then you can call class A, or you can insert class A in this mixin class, or for the second example, the mixin ID. And what it compiles to is it takes a look at where can I select A, takes all of those style definitions and adds them to the mixin class. A second example of mixins. Here you see a nesting behavior as well. We have the myHover mixin class, and inside of it we are using the hover selector. If you would write it, you see how it looks in CSS. It compiles to take out the nesting and append it to the parent selector. And the button is calling the whole mixin, which makes all of those styles and definitions append to the button. So we talked about about manipulating the DOM with JavaScript before. Now we can add styles to the JavaScript. Okay, I'm going to rush a bit. We can add styles by calling, for example, getElementById or selected by jQuery, and add CSS styles as we want to. Furthermore, we can add whole CSS classes, which is pretty cool when you have a kind of click event, for example, and you can swap the classes of the button, for example. So the class is added inline to the element. So, and this is the example I introduced when Christian asked about animations. Well, actually, it doesn't look that good. It worked before. This whole animation is done in CSS. I'm not sure whether you can read it, but it says, when Chuck Norris does a push-up, he isn't lifting himself up, he's pushing the earth down. And what you see is, for example, the background is rotating, and you have his foot. Okay, I think I damaged it before. I rerun it, yeah. Now it's better. Beside the rotating background, you see that the feet are changing as well, and the arms are doing the push-ups, and yeah, some blinking on his eye. And those animations are just done in CSF. As if you take a look at the JavaScript part of this CodePen embed, it's empty. It's just plain CSS. And the cool part is this is widely supported, and you don't need to load heavy animation libraries. Yeah. Do you have any questions to our topic presentation so far, before we might go on?
Why CSS animations are better than JavaScript animations?
Actually, if you do, it depends heavily on the framework you're using for your animations. But if you use, for example, jQuery to make some fade-ins or something like that, the performance is different to CSS animations. However, the browser support is pretty different as well. If you compare the performance of CSS animations in Firefox and Chrome, you get pretty different results in my experience. If you ask why it's better, it's because CSS is there and you just can use it. And if you,
JavaScript.
But not okay. You can do animations in JavaScript, and if I want to fade in a button in plain JavaScript, it's like this bunch of code. It works, but it's not what you want to. And if I want to fade in this button or in CSS, it's just one line. So I was about to compare CSS to some animation.js libraries, because no one wants to animate in plain JavaScript, I think. And those libraries are not there by default.
I think the main difference is that you have hardware acceleration with CSS, which you don't have with jQuery.
That's true, yeah.
And that makes the performance difference. So, like, CSS animations are done on your GPU, if it has one, and while jQuery animations are done on your CPU. And thus limited by the threading capabilities of the browser. Firefox, which only runs in one process, is pretty shitty about that, while Chrome has a process for each of the tabs, so it has better performance in that sense of matter. When you use CSS animations, it doesn't matter.
Is there any difference with the energy consumption?
Of course. CSS will consume less energy because it's run on the GPU and uses less CPU power, I would say. That's my assumption.
Yes, as far as I know, they do indeed use less power. And in the age of mobile, it's one of the most important.
You have to be like conscious that CSS animations are run on native code in the browser, while JavaScript is run inside the sandbox of the browser. So it will be slow.
Thank you for that.
Any more questions?
Why to use plain CSS, not Sass or less? Do you know Sass or less?
You mean why we put on the less examples?
CSS or less?
Yeah, example.
Ah, sorry, I missed it.
So we showed an example of some less stuff, basic variables and mixins. And I showed the advantages. I think that's enough.
Right, let's move on.
Okay, let's move to the project where Group 9 is joining us.
And let's do this in less than 10 minutes.
Then I'll be fast.
Who's the next group to present?
Group 9.
All right, bring your laptop over here so we can switch really quick.
Okay, so we're Project F. I'll make this fast. We're Project F. Because it's two teams, we are responsible for making the awesome work the other groups did, present it in a nice way to the users. So first, all the input that we have the PLOD, the likelihood of death of the characters. We have the character location association on the map, and also we have the Twitter sentiments of the characters. So in the beginning, we have the first page, it's going to be the home page, having the topmost PLOD, and the top 3 character sentiments, and the flop 3 character sentiments. Also, we're going to have the map, which does show the association of the characters on the map. On the second and third page is going to be the characters. First part of this is going to be a character catalog where you can sort them by name or by their family or their appearance in the episodes. The second part of this is the character detail page. We're going to have basic information about the character. We're going to have the two sources of the PLOD from the two groups, as Christian suggested. We're going to have the sentiment from the last episode, and also we're going to have the character location history on the map. And we come to the last page. It's the About page. We're going to have the link for our projects on the GitHub. We're going to have the collaborators and tutors. And we're going to have highlighting the APIs. Also, one idea, nice to have, is to fetch the images and the names from the project through GitHub API. And now on to some preliminary mockups. So this is how our homepage is going to look like, with the most likely to die soon, most loved on Twitter, and the map on the bottom. And after this, this is the also preliminary mockup for the character page. We have like the image and some info, and then the PLOD and the map. And now on to the hosting with Yasha.
Yeah, we thought about the hosting pretty early, and we informed ourselves about Amazon, Google Cloud Platform, and Heroku. And yeah, finally we got to the conclusion that we want to use Heroku for our testing deploy server, because we don't want it to provide a credit card for Amazon and Google Cloud. They needed to get a credit card from us, also, and the problems of Heroku with that it sleeps after 30 minutes and it has to sleep at least 6 hours a day are not that bad if you are just developing and not really deploying. So, and yeah, Heroku is really cool with it. The next thing I want to mention is we used Webpack. I wanted to try it. I haven't. Webpack is what is Webpack? Webpack is something you call it if you want to start your deploy server, and it manages to grab all your it preprocesses all your files and bundle it and make everything for you so you can just work on it. And it also have a build functionality that it can minify and uglify it and bundle it really into one JS file and one CSS file and these things. Is that enough, or?
It will be explained more in what's the 18th in Project E topic presentation. It will be explained more tomorrow. Yeah.
Okay.
Okay.
But can you give us like one line on what it looks like?
Yeah, it is build and bundle manager. So you can build and create a bundles with it.
How is this different than the other solution?
So, for example, profile needs attached runner. What I understood, you can't run it by itself, and Webpack apparently doesn't necessarily need one.
Okay. Fair enough.
So the cool thing about Webpack, it is not very configuration heavy. I haven't compared it to, I haven't used Grunt yet, but I read that it's not that configuration heavy. And it also makes bundling and compiling easy. I'm using a functionality called loaders, but it will be explained in I think tomorrow or later. And yeah, you can compile everything and bundle it. Yeah. So in the development part, we use the Webpack dev server. So we can work on it, and it's watching our changes on the files, and we actually have a plugin called hot module replacement integration. So hot module replacement, and that changes the only specific parts of our files. For example, if we change it changes only if we change React components in our files when we develop, it changes only these modules and replace them. So it's extra for an extra plugin for React. And it's like instantly reloading. If you save the file, it's instantly reloading on the browser. In the builder, as we said, we're using the Webpack, the React Webpack package, and it uglifies and minifies our code. And normally the CSS is loaded into the HTML document, and with a plugin provided by Webpack, we extract it into a separate file. Yeah, we do. Now I want to talk about how we deploy. That will be talked about by the other group too, but I want to mention how we deploy. We deploy it using Travis and Heroku. Travis can deploy on many different hosting platforms, and yeah, we just okay. Normally there's there at the bottom is it. There's the code of our Travis file, but it's not that important now. And Heroku needs a proc file where we just say he has to start a web worker and serve our and run our server.js, which just serves our compiled and bundled files. So yeah, we actually got a domain by Heroku where we just can go on it and if it loads, but it's inside the browser, I think. So
yeah, it looks like there's no connection probably.
Yeah, okay. That's if you want to go in it, it's responsive and it's actually loading. Okay.
Yeah, the Heroku worker was done probably.
Yeah. So it's mobile friendly, and we have not much content at the moment, but we work on it, and yeah, good. Now I want to talk about some problems we had. A week ago there was a big communication problem about the integration and how we haven't much communicated with Project E, and that is now much better. And another thing is the task distribution. We haven't really we hadn't a good task distribution back there, and now we have it much more organized using GitHub issues and Slack. And the communication is with Slack and GitHub much better now. And we have some technology issues using React and Webpack, because it's like pretty new to everybody, especially React, and so it's kind of difficult to work in there.
What are the current technological issues that you're having?
It's like understanding issues, how React works, and how to code in it, and yeah. Okay. Because it's not familiar, none of us is really familiar with it. So.
How many of you are actually working on this?
I like all. React, it's kind of new.
And you're all working on React right now, trying to understand how it works?
Yeah, it's.
How about you? Sorry. How do you? Okay, so tell me how you distribute the tasks and what each of you are doing.
Yeah, everyone does a separate page. We just set up the infrastructure and then went from there and distributed the tasks.
All right. So what are you doing?
I'm, for example, doing the landing page with the likelihood of death and the most loved ones, and also the map, and also with Mina we're working on this together.
Doing the character page right now, and most probably only this because it's enormous information load.
I did some mock-ups and the base styling and layout of the page, and now I'm heading to the About page, or into the About page.
I'm just there for information about React and Webpack, and I'm kind of organizing this, and I'm behind of the deployment of the app to our GitHub, to our Heroku page. Yeah, and I'm going into deploying into whatever you give us in the next days. I hope we get it the information soon. Yeah.
Okay. What else do we have here? That's it.
Yeah.
We're done with the problems?
That were the problems.
That's the last slide, problems?
Yes.
Good. Not a social page.
All right. When do you? When are we going to see some content flowing in there? What is holding you from actually showing us? For instance, actually loading some apps.
The integration is a big problem because we don't have reliable providers yet to reliable libraries we can use at the moment. We haven't included the Project A, for example. So we have an API which we can use at the moment, and yeah, that's the main.
What do you see happening in the next? I don't know. Today, Thursday. Let's say until Monday, Tuesday.
Yeah, we said until 21st is the layout done, and we will have the design for the layout pretty much covered, and we have then.
You already have the layout. You know?
We are working on it. Yeah, that's what what you have seen there, and on the actual page is not that what we have got at the moment. We have also already included the map on the home page. And yeah, and we had some days ago we had done the mock-up for the character details page, and this is really easy to.
So the character details page, by the way, is this a mock-up right now? Is this static or is this being built dynamically?
The mock-up, as you have seen, it isn't the actual state, but it's almost there.
Like that, the idea that would depending on the integration. So we make web pages, the layout ready for data injection.
So for instance, like the characters image, where are you pulling this one from?
Well, that's why we don't know how the integration is going to happen. So we're going to put like JSON, send JSON, dummy JSON to it, and the web page is ready. And then the second part, after the 21st, when the integration is done, just inject the data into it easily.
We discussed with A that they are fetching the images and storing them into the database, and that's the plan where to fetch them from.
Do you have some model which is already built? Because you know that the thing that takes up most time in coding a web application is design of the front end. You're aware of that, right? So it takes time. It's not like they just can expect them to give you the data in 5 days and then in 1 day you have the
yeah, that's why we already started with placeholder images and so on.
Okay. Is there anyone in the team which has experience in user experience and user interfaces?
Yeah, a bit.
Okay. You might want to read articles about user experience and user interfaces. Just so you know.
Alright, thanks a lot. And we can talk after this. Alright? Want to get some more
Yeah.
Okay.